Welcome back to OCR MEI Further Mathematics B. Today we're doing chapter 6.7, Integration by Trigonometric Substitution. So let's apply what we've learned last time about the inverse trigonometric functions. So before you do these questions, make sure you put it in the correct format, and that would require you to factorize. So we're going to evaluate this particular integral. So we have 1 on the square root of 4 take x squared. From this form we cannot tell, we cannot say much about this expression because any substitution that you do would not work unless you try a correct trigonometric inverse substitution. We can do that, but we can also do it the more direct way of rather than to have to use all those substitution of the form of arc, sine, cos, or tan. We can just make it such that the expression looks sort of like the expression of the differential of an inverse trig function. So this sounds very complicated, but I will recall you that arc sine differential, so d by dx of arc sine x is equal to 1 over square root of 1 take x squared. So let's keep this in mind for now. So let's try to rearrange this expression such that it looks like the form on the right. So the first thing we can do is to factorize the bottom bit. So we ended up with 1 on square root of 4 times 1 take x squared on 2. Actually this is on 4, my bad. So we've got this sorted. Then this square root of 4 can be factorized out to 1 on 2, because the square root of 4 is 2, multiplied by 1 on square root of 1 take x squared on 4. Okay, this pen is starting to malfunction, which is bad. And my voice is starting to malfunction as well. So over here we have the first two part identical except for the x squared bit. We have x squared on 4. Luckily that can be turned into x on 2 or squared. So this is equal to a half of 1 on root 1 take half x or squared. So now we have a certain expression that would look a bit nicer. So what we can do here is state that x on 2 equals to u as a substitution. Then we have an integral dx. What we need to do is turn this into an expression of u. So dx is equal to, actually half of dx is du, which gives me 2du equals to dx. This is just simply differentiating this to get an expression of du and dx. So we've got this. Substitute for the dx, we get integral half 1 on root 1 take u squared du times 2. The 2 cancels, which will give us this expression 1 on root 1 take u squared du. Turns out that this is arcsine of u, so we have integral of the d by du in this case of arcsine of u, just u, not u on 2. What a mess I am. With this set, these two, well, the du as well, these will cancel out totally, and you're left with arcsine of u, which turns out to be x on 2. Make sure you have the plus c afterwards, but that's all for how to use trigonometric inverse substitution. So the key point is that you know your form, your standard forms of your inverse trig. You can manage to factorize these expression into the certain ones, and yeah, basically if you do the unit conversion or variable conversion properly, then you should be able to get something nice like this. So that's it for the examples. So for this tip section, I'm just gonna say, when you do integrations and you're stuck at some certain questions, try to substitute the inverse trigonometric functions, because that would most of the time that would help. If it doesn't help, then it's probably another type of substitution that you need to learn during chapter 8. It's something to do with a function called the hyperbolics. Turns out it is also exceptionally similar to trigonometric functions, and I'm gonna talk about that more during that section. So this time I'm gonna give you these two questions to carry on with. Evaluate the following expressions. So just substitute trigonometric functions and see what happens. That's all I can say, to be honest. So I'm gonna give you, as usual, 5 seconds to get prepared, and I will show you the answer in oh dear. I'm gonna show you the answer in 5, 4, 3, 2, 1. The solutions are shown right here. So the first one is an arcsine, and the second one is an arctan. And remember to add c. That's my bad. Yeah, basically that's it for this question section, and that wraps up this video as well. So thank you very much for watching. I hope you've learned something. If you have any questions, do let me know in the comment section below, and I will try to help you as much as I could. For now, thank you very much for watching, and I will see you on my next one.